In this example, we want to write vector v, the vector 3, 2, 1, as the sum of vectors from the span of 1, 1, 0 and the orthogonal complement of that set. So in this set, we're looking at things that are multiples of 1, 1, and 0. Here, we need things that are orthogonal to it. So let's start by finding the span of the orthogonal complement. Okay, so if I take a vector A, B, C, and I dot it with 1, 1, 0, that gives me, and this dot product is equal to 0, this would give me orthogonal vectors 2, 1, 1, 0. So this is going to be A plus B plus 0C equals 0. So I'll let S be equal to A, which means B is equal to negative S. And then C can be anything. So we'll let T be equal to C. So the span of 1, 1, 0, the orthogonal complement to that, are things that look like S times 1, negative 1, 0, plus T times 0, 0, 1. Okay, so everything that's orthogonal to this either looks like that or looks like that. Okay, so let's try and write V as a sum of this guy, this guy, and this guy. So V is going to be, let's say, alpha times 1, 1, 0 plus beta times 1, negative 1, 0 plus gamma times 0, 0, 1. Okay. And we can quickly do a little arithmetic here. Obviously, the only thing that deals with the third component is gamma. So to match up my V with this guy, it means that gamma has to be 1. Now, how about my alpha and beta? So we've got 3 is equal to alpha plus beta, and 2 is equal to alpha minus beta. Okay, so if we add these together, we get 5 is equal to 2 alpha, or alpha is 5 halves. And if we have alpha equals 5 halves, 5 halves plus another 1 half is equal to 3. So beta equals 1 half. Okay, so alpha equals 5 halves, beta equals 1 half. And as we discussed earlier, gamma has to equal 1. Okay, so V is equal to 5 halves times 1, 1, 0 plus 1 half times 1, negative 1, 0 plus 1 times 0, 0, 1. And that's it. And we know that we can always do that for a vector because all the vectors that we're talking about, the 1, 1, 0, the 1, negative 1, 0, and the 0, 0, 1, those are all orthogonal. Because they're all orthogonal, we should be able to make the span of that grouping of vectors should be able to make any vector of the same dimension.